So what is Terraform? Why do we need it? Let's have a look at it. So Terraform is a infrastructure provisioning tool, right? Like till now, if you see our CI/CD pipelines, we have automated everything except creating the instances, right? We are manually creating the instances. So this Terraform can be used to do that infra provisioning, right? It can be used to modify the infrastructure. It can be used to replicate the infrastructure and scale the infrastructure as well. And using this, we look at the infrastructure in the form of code, which is nothing but infrastructure as a code concept. So we know that we write the code for development, testing, and all. Here we use the code or we look at the infrastructure in the form of code. And Terraform is one such tool which help us with that. Right. So let's see what it does. So it's a tool for building, changing, versioning infrastructure safely and efficiently. The advantages are like we can use it to replicate the infrastructure, we can use it to scale the infrastructure, modify, and also version control. Like if you want to go back to the previous state of the infrastructure, that's possible, right? Because we are using code which represents the infrastructure. It's an open source tool and uses declarative language. Right, and it uses infrastructure as a code concept and it is written in HashiCorp language. HCL is used for Terraform. It uses infrastructure as a code concept, IAC, right? Where you look at the infrastructure in the form of code, you can version control it as well. Those are the major advantages of using Terraform. And you have other tools which uses IAC as well. Ansible is another such tool which uses the concept of IAC. And because it uses the concept of IAC and it overlaps with the functionality of Terraform, there is a lot of confusion on when to use Ansible and when to use Terraform. See, Terraform is like it can be used to provision the infrastructure. It can be used to configure as well. But Ansible is great in configuring the infrastructure, whereas Terraform is for provisioning the infrastructure. And Ansible is a more mature tool, and Terraform is a quite a new tool. And both uses the concept of infrastructure as code. And coming to the architecture, Terraform has two components, core and the providers. Core is the actual component of Terraform, like the main component, the core component, which does the actual provisioning, right? That's a main component. And the other component are providers. Providers are like extensions or plugins or add-ons, whatever you call, or executables and programs. So whichever to whichever API you want to automate, there's a provider for it. There are hundreds of providers. We'll come to the provider in a while. Let's talk about what core does first. Core and providers are two components. If you look into the core, it's the main component and it takes two inputs. Terraform configuration files, which is nothing but Terraform users write what we write to provision the infrastructure. Core takes this input and compares it with the state file. State file is nothing but the actual state of the infrastructure would be present. Whenever you create the infrastructure with Terraform for the first time, state file will be created automatically, right? That is automatically created when you does the Terraform apply for the first time. And it will have the actual state of the infrastructure. Terraform configuration is the one what you write as a Terraform users. Right. So whenever you write the Terraform configuration file and whenever you apply it, like let's say you want to bring up that infrastructure, you apply it. So this will create something called Terraform plan. Terraform plan is something at a document which will have what kind of infrastructure should be provided. Means what, let's say what are the steps to be done to give the expected infrastructure. See, this expected state will have the actual state of the infrastructure and this state file will have the actual state of the infrastructure and this Terraform configuration file will have the expected state of the infrastructure. So let's suppose actual state is 2 EC2 instances are there. Terraform configuration expected state is it should have 3. So when you apply Terraform, it will create a plan with all the steps of what should be done to make the infrastructure 3 instances. right? So that kind of steps will be created in the Terraform plan. And that Terraform plan will be fed to the core component. Core is the actual or the main component of Terraform, which take this plan, which take this input, and using the provider, okay, it will take the input, which is a Terraform plan. But how does it provide the infrastructure? It will create a plan, and the plan will have steps of what to be done to achieve that expected state. So, but how does it achieve it actually? That's where comes providers. For the plan to get implemented, it will use providers. Providers are like extensions or add-ons. For each API, you have an extension, you have a provider, so that you interact with that API using the provider. Like, let's say there's an API, you want to automate the AWS components. So we'll be using a provider called AWS. So that's how you have core and providers, the major components. Is this much clear, everyone? Any questions here? So Terraform works on Windows, Linux, and Mac, and these are the three operating systems it supports. And version control Terraform files with Git. Like you can use Git to version control the Terraform files. And providers are logical abstraction of an upstream API. They're responsible for understanding API interactions and exposing resources. Terraform has vast number of providers for AWS, Azure, GCP, and so on. Each provider offers access to hundreds of resources. Like this provides an abstraction of an upstream API. They are responsible for understanding API interactions and exposing the resources. Terraform has vast number of AWS, Azure, GCP, Kubernetes, and so on. Each provider offers access to hundreds of resources, connective providers. So that's what providers does. Resources, data sources, and so on. This is all comes under hands-on, but before we go for the hands-on, let me show you the providers. So when you go to the providers in Terraform, here you can see browse providers. Right. See here, providers are logical abstraction of an upstream API. You can connect with any API. You can send the API calls with these providers. They're acceptable and understanding API interactions. So these are the providers, right? You have different providers, AWS, Azure, Google Platform, Kubernetes, and all. If you know one provider, you can work with any provider in a similar way. Okay, so let's go to this AWS provider. So if you see here, lifecycle management or AWS resources, including EC2, Lambda, EKS, ECS, VPC, S3, RDS, DynamoDB, and more. Right? These are all the services you can interact with. Three examples. And how to use the provider also here. Use the provider. So this is the block you have to add so that it will download this provider. And then if you just go to the overview, or documentation. Yes. Here you can see on the left-hand side, lot of resources. These are all the resources of AWS which you can automate. For example, AWS EC2 resource. See here. This is the AWS EC2 resource. This is the AWS EC2 service, and these are all the resources we can use. How to use it and all will be defined in AWS documentation is great. You can learn with the documentation itself. It is documented so well, and it helps Terraform users with all the sample snippets. Terraform is again, can refer Terraform code from this official documentation, right? So these are all the providers you have. And there are something else like modules as well. We'll talk about them as we progress. So with this, we can get install Terraform install and get started with the Terraform. Let's get started with the installing Terraform. Download. Any questions, please let me know. Terraform download, you can go to this official website. You can install Terraform on any operating system, right? You can use Terraform in your local, in your laptop and automate infrastructure on AWS, or else you may create some EC2 instance on AWS and automate Terraform. Anything should be fine. So you can see here, Windows, Linux, Mac, right? Depending on the operating system you need, you can download it and install it. I have already installed on my local. If you want to do it on any Windows, Linux, depending on the distribution of your Linux, see you have all the steps. As of now, I'm going with installation on my Mac using brew command. I'll be also installing on EC2 once we progress. Okay, for the pipeline, we'll be creating it. So this is my EC2 instance. I have got my Terraform installed. Let me create some Terraform directory to write the Terraform configurations. Now I would like to open that in the VS Code. Just created some empty directory. Launch it from here. So now this is just an empty folder. So here we can create some Terraform configurations, but firstly to initiate Terraform, we can create a file. This file can be of any name, but generally we give the name as main.tf. So here we would like to call the provider, right? So we can write, and by the way, one more thing, Terraform doesn't come by default with all the providers. Okay, because providers are executables which are heavy. So whichever provider you need, you can configure it. Here it is there, right? So Terraform block, required providers block, and Terraform configuration block. So this is what we would need. That's all. This will install, this will initialize this particular provider, AWS, by installing this particular version from HashiCorp AWS. So let us install it. How do you do that? How do you initialize Terraform? Terraform init. So you can see here Terraform is configured. Right? Do you see that? And one more thing happens if you observe. If you see on the left hand Windows Explorer, you can see here. You can see here the Terraform folder. What is this Terraform folder? It will have .terraform providers and you will have the executables here. You can see this is the executable. I'm sorry. So this is where you can see the providers. And also there is one more thing, log file is created. This log file will show the which version of providers it has been used. Right? If you want, you can just check in the Explorer as well. Like on the desktop in the Terraform folder, we'll have this main.tf. You see this? And this is the Terraform log file. But here is the executable which is downloaded. The AWS HashiCorp executable version 6.4.0. This is the one, right? So those are the configurations you have, right? So Terraform provider is available. Then what next? Right. So then, like, what is this provider? Okay, AWS provider is available, which will help us connect to that API. But then, like, how do you connect to a particular AWS instance, isn't it? So that's where comes, like, you can provide here the AWS credentials. How do you know, like, how to provide and all? You can refer the documentation for anything. This is again like open book exam where you can refer this. So if you just scroll down, you will see AWS region access key, secret access key configured as such, right? We can do the same. Provide the AWS access key, secret access key. But this is not the right way, right? It's not a secure as we would be pushing our code to version control systems like GitHub. So rather what you can do AWS configure on your shell, right? So this is one way to handle this credentials. We can configure on our shell with the access key, secret access key, so that when you version control it, it wouldn't be any problem, right? So that's one way. Now it is also connected. Now you can connect your AWS, but what do you want to do when you connect to AWS? You can do anything like creating an EC2 instance or creating an S3 bucket, all of that you can do. Let me create an EC2 instance. But let's say, how do you create an EC2 instance? You can search here for whatever instances you need. This is ABS. Builder, ECR, ECS. AWS instance. This is the actual instance. It provides an easy to instance resource. This allows instances to be created, updated, deleted. It supports infrastructure provisioning. So here is the okay, ignore this one. This is the one. Resource definition, resource block. Type of the resource is AWS instance. And this is the name of the instance. And then AMI instance type and so on. So this is your okay, see here resource type, type of the resource, name of the resource, and we would put the AMI here. What is the AMI? What is an AMI? Till now we have used EC2 instances, and what is an AMI? We'll put the AMI here. Type of the instance is T2 micro, and the tag will be the display name. So this is what we want. Let's go to our AWS. Yes, AMI is the Amazon machine image. Just a second. Mm. So whenever we create an instance, we just go here and Amazon machine image, AMI, right? This is your AMI ID. This is your AMI ID. Like if you choose your Linux store 2023, whatever, this is where you see your AMI ID. This AMI ID changes from region to region. Here you see the list of the regions. These are nothing but the physical data centers of AWS, right? So depending on the region, they would change. Also, whenever there are any updates, this AMI may change. But as of now, I'm hard coding this AMI. Okay, and then the instance type is T2 micro and the tag is hello world. So I would like to create with this. So I have initialized the Terraform, right? And then Terraform plan, this will create, like I told you, right? Whenever you, before you apply, you can run the Terraform plan. This will create this will show you what happens when you apply it. It will not really apply the changes. It will create a document with all the steps what are necessary to create this infra. So let me run Terraform plan. It will show you what are all the changes that would happen. Just scroll up. Plus indicates those are all created. See here, create. Plus indicates infrastructure will be created. Instance web will be created, which with all these particular attributes, out of which all of them will be known after apply. Two values I have applied, like region and the digest check is true. That's the default values. And then T2 micro. So these are all the values that would be created. So, but they are not actually created at this point of time. For them to get created, we have to do Terraform apply. Terraform apply will again ask for confirmation, yes or no. You should confirm it with yes to proceed. And whenever it is doing apply for the first time, like we discussed, right, it will create something called Terraform state file. Terraform state file will have all the configurations of your infrastructure. Okay, it says infrastructure is created, one resource got created. First, let's see that on the UI. Instances. See, tag name. This is the tag. If you go to tags, you will see that name tag is hello world, name tag is display name. And you can see this is your infrastructure. Okay, and it should be using the AMI which we have assigned, this one. Perfect, right? And it was in running state. The step is automated infrastructure provisioning, right? As simple as that. And at the back end, whenever you do this, Terraform state file is created, a JSON file with all the information of your instance. It will include all the sensitive data as well, including IP address, everything, right? So that's how infrastructure is created. What if you rerun the Terraform apply? It will compare the state file with the plan document, and if there are no changes, it tells you that no changes needed. This is called idempotency. All the infrastructure provisioning tools and the infrastructure configuration management tools like Terraform and Ansible implements this concept of IAC uses idempotency, right? So idempotency is all the configurations in place, so it will not reapply if you want to make any modifications. So we saw creating an infrastructure, modifying, let's say you want to give the name as Terraform instances or TF simply. Now, if you run Terraform plan, before applying, you can run Terraform plan. It will show you tilde, which indicates updates are in place. Okay, here you can see hello world got changed to TF. And Terraform apply. One changed. Right? One change happened. Tilde indicates there is a change. Let's see. Yeah, do you see that? So you can use Terraform to modify infrastructure, to provision, we have seen to create the infrastructure. You can also use it to configure the infrastructure, modify the infrastructure, right? So provisioning modifications we have seen. Can you like replicate the infrastructure? Let's say I want to have two. Okay, before all of that, one more important thing we have to do. Like see here, we have created this state file and state backup file will show the previous state of the infrastructure, right? All of these files like state file, state backup file, and this Terraform providers need not be version controlled, right? Those contain sensitive data. So how to do that? That's where we can use dot git ignore. Right, dot git ignore. We have learned what the purpose of dot git ignore. Now we'll use it for the real use case. So you can use it to ignore all the state files, right? First, the Terraform folder, which will have the provider. Providers need not be version controlled. They're executables, right? Everything in that folder should be version controlled, or should not be version controlled. Sorry, dot Terraform. Okay. So that should not be version control. Also, all the state files. So I would like to put tf state dot star. So it should ignore all the state files. Let's see. First, let us in a Terraform git init. Okay. Now git add Terraform state file has got ignored if you see, right? Actually, here need not be, yeah. Now, here also, backup file is grayed out. This should also not be version control. Okay, we'll modify that. So using the while characters, I'm ignoring all the state files and the Terraform provider. See, this is the practical implementation of using state files, right? We have used state file to ignore some dummy file, right? But this is the real use case of using state files. Any questions from anyone? State files, because we are ignoring them because they have sensitive data. And dot Terraform, it's a executable. We don't have to version control it. Star dot df state. It should be ignored. It's okay, we'll see. So this is what we have. And the status like dot git ignore. Let me add that. Git add. Okay, that's committed. Okay. Git commit. minus am ignore file. Okay. So dot Terraform folder, everything should be ignored. Okay, ls files. Let's see what are all version control. Dot Terraform folder is ignored. Terraform log file should be version control. TF state is getting a version control. It shouldn't be the case. Or did I write dot TF state? For some reasons, it's still version controlling it. If I remove this, then also it is version controlling. Okay, we'll sort it out. First, let's see. So this is how you can use Terraform to create, modify. And what do you want? What if you want to replicate it? Like I want to create multiple EC2 instances. Just now we get started with one EC2 instance, right? What if you want to get started with multiple? And that's where comes something called count parameter in AWS. Using this count parameter, this is called a meta parameter, like count. Okay, two instances I want, right? You can use that. Also, here count will have an index starting from 0. So I want to assign that here for Terraform instances as a name of the instance. See count dot index. Because count starts from 0, it would say +1. It's asking us to add +1, but this is enough. I don't want to add +1, just I want to see starting from 0. Right? So now two instances should be created. One is already there. Right? It should create one more. That's what it would do rather than creating all of them. Let's see. Terraform plan. Okay, it's saying one to change, right? One instance name will be changed, another one is created. That's what it's showing. One will be created, one will be changed. TF will be changed to TF0. Okay. Now Terraform apply. We should see two instances, even those two instances information should be present in the state file. See one resource added and one changed. Let's see. Yes, here you can see Terraform 0, the old one, and the new one is the second instance, Terraform 1, and it's an initializing state, both using the same AMI, right? Got it, everyone? That's how we can use count parameter. I'm showing you the Terraform lifecycle, creation, modification, replication. Of course, this is not replication, this is scaling. Replication means replicate, let's say this is my dev environment. You want to replicate the same infrastructure for test and prod. That's a replication that will create, go ahead with them in the subsequent classes. And coming to the state file, it will have all the information, right? Let's suppose you just want to, any information you have to search this. Rather than searching this, if you want to see the list of the instances, Terraform state list will show you two resources. Each resource is referred as type of the resource dot Name of the resource. Web.0 means first one. Web1 means means second instance. And state show that particular instance. If you want to see details of any particular instance, you can do this. Terraform state show. Use the bash shell rather than G shell so that all these commands would work. Bash. Right? That's the difference between bash and G shell. So it's showing all the details, correct? All the resource details in which availability zone it has got created, what is the state of it, what is the ENI, IP address, DNS, everything. That's how you can use state commands to see all the details in the terminal. And let's say I want to see some of those details. I want to print them. See, most of the times you may not have access to the AWS console. In such cases, if you want to see the details, you have something called output blocks. Like resource block, you have output block. Give any name, let's say IP, and then value equal to. If you want to see all the instances, web star means 0 and 1, alright, and their public IPs. Okay, so some description. See here, web start means 0 and 1. It will print both public IPs. If you want, you can also see for private IP. See here, this is the object, instance dot, name of the instance dot. You can see all of these details, right? This dot will give you all the attribute values of that particular resource. If you want to see private IP, you can do that, right? Let's say description is private IPs. Because private IPs are fixed, I just want to see here. You can again run Terraform apply. Terraform plan. The output is changed, means it should display the output. See outputs, it was already showing us. Then let's do Terraform apply. Whenever you do Terraform apply, it will ask for confirmation. You should provide your yes. See outputs are printed. Understood? State list, if you go here, it will show in the JSON, or else you can print everything in the command line. But if you want to see some outputs on the terminal specific attributes, you can do this way. Got it, everyone? Understood? All of these blocks are referenced from the official documentation. You can refer that and use it. If you want to see ignored files, there's another command, ignore. State file is still ignored files, state backup file is there, but this one is still version control. We need to change it to discard the changes in the working directory. We'll see a pattern to ignore it. Okay. So this is about creating, replicating, and let's say you want to destroy the infrastructure, right? You just want one instance. I'm commenting the count parameter. Because count parameter is commented, I can't use count.index. Means it will just have one instance, right? I removed this, means this block will just create one instance. And here also, because there's no count meta parameter, we don't need this. We to refer as with index number, we just have to refer as web. This is the name of the instance. Now let us do Terraform apply. If you don't want to wait for the prompt, you can give here auto approve so that it won't wait for your input confirmation yes or no. You have given here auto approve. See here, the destroy will be shown with a minus. Resource will be destroyed. One resource will be destroyed and one resource will be modified. Name should be modified, right? Simply as Terraform. Earlier it was TF0, TF1, but now it should be simply TF. See, that's what is happening. The other one is getting shut down. Do you see that? It's getting shut down. And you'll just have one instance and that public private IP will be printed. It already printed this, right? That's how you destroy the infrastructure. Okay, what if you want to destroy the complete infrastructure? You can use Terraform destroy. Again, this also needs auto approve. If you don't provide auto approve, it will ask for confirmation. Yes, it is showing only destroy. So you can see one resource destroyed, right? Also, Terraform state file is empty. Do you see? Because no infrastructure. State backup file will have the previous state of the infrastructure, right? So that is what it is. Here, if you see, infrastructure should be destroyed. Whatever we created with Terraform are all terminated, right? So creating, scaling, modification, destroying. But okay, now I don't have any infrastructure created with Terraform. But here, if you see this part, it tells you, means your code tells you there is some infrastructure. So this will create, but if someone looks at the code it represents, there is some infrastructure available, but actually there is no infrastructure available, right? So it's always a good practice that your code should represent the infrastructure. That's what is IAC. But here your code represents as one infrastructure, one EC2 instance, but as per the reality, there's nothing. So always the better way to destroy is remove this code. This is always the better way. Okay, that's how you should destroy rather than running destroy command. But anyhow, now because it's already destroyed, it says no changes. Right? That's a Terraform lifecycle, installing Terraform, um, creating the infrastructure, using a count parameter, and using the output block. You can create any infrastructure. It could be your S3 bucket or anything. Let's just come here. If you want to use S3 bucket, S3 is nothing but simple storage service or AWS, the first service. If you want to create S3 bucket, yes, it's here. Resource, some name and the bucket name. That's all. Let me just show you this. S3 buckets can be used to store some files. As of now, I'm not storing anything. Just I'll create some bucket, that's all. Let me clean up everything to keep it simple. Let's say that's a bucket name. Okay, bucket name should be always unique. Where is your S3 bucket? Just go here. Search for S3. It's a simple storage service where you can store some files or any configurations can be stored here. You just go to S3. So create a bucket. See here, like you go and create a bucket, I'm just creating using Terraform. That's all. Terraform, apply auto approve. It says missing required parameters. I think there were some required parameters which you need to provide. It's saying key is required. Key is equal to, let's say, index.html. Okay, key is some file in the bucket. Okay, it says it created but again failed. Put permission. It needs to have permissions. Let me give here. ACL is private. Okay, let me just add the next one also. Tags also. Um, okay, just let me use all of that. Again, the specific bucket does not exist. The bucket should be created. Hmm. Sorry, this should be the name, but object can be the name. Bucket. No such bucket. The specified bucket HTTP response code does not exist. Uploading a file. This is for uploading a file. First of all, bucket should be available. I just want to create a bucket. So, servers, history object log. Resource and the bucket name, and then that should be there. Okay, firstly, initially I did the same, right? That's okay. Let me try this. First bucket should be created, then only you can upload the contents. It's saying document key is required, but no definition was found. Provides S3 bucket. Haven't I used the same? S3 bucket. Oh, sorry. I am using something else like object. Object will help you upload something into the bucket. But the resource name is S3 bucket. See here, I have used incorrectly. This is the one which provides an S3 bucket resource. It is S3 bucket. It's not object. If you want to upload something, then it is object. So let me try it out now. It should create that bucket. Now still one more error. S3 bucket, create bucket. Creating S3 bucket, operation create bucket. Bucket already exists. Bucket is created, I think, already. Okay, bucket name should be unique, right? So that could be the problem. But bucket name should be unique across AWS, not only in your account. So bucket by that name already exists. That's why it gave error. Now it's creating. Do you see that? So it has created. Let's see that. Do you see the bucket? But you don't have anything in the bucket. Now we can upload it using, what did I use earlier? Resource. So it gave us all the details. A bucket object, bucket name. Bucket name, how do you refer? I want to upload to a bucket which is created previously. So how do you refer it? First, the bucket type and the name is example dot bucket. Okay, that will give the name of it. And the key is it should have index dot content should be this and so on. Let me give it a try. Terraform apply auto approve. Creating. I think it has got created everything. Let's see. So now if you refresh and if you just go there, I don't see index.html. We have added content also. If you want to just see, just go there and open that. Yes, perfect, right? Hello world is the content I added into that file. Clear everyone? So first creating the bucket and then adding some content into the bucket. That's how the Terraform document can be used to refer and automate things. Any questions? You can do many things. You can see here. Bucket is created, and if you want to manage the objects, you have another one Terraform bucket object, right? Uploading a file. Let's say from your local, if you want to upload source path, key is nothing but the file name and the bucket name, right? So if you want to encrypt it with the KMS key also available. If you want to upload any key files, object logs, all of that. And by the way, there's so many parameters used, right? But we may not all use all of them, or else we don't know all each and every parameter. To understand parameter argument reference is here, right? What is region? What is key name of the object once it is in the bucket? Once you upload the file, what is the name you want to keep it? It is very clear explaining this. ACL is canned access control, right? Whether you have a private or public read, what kind of access you want to give. Cache control or content disposition, content language, you have all these parameters to provide, right? So log configurations, if you want to see, bucket policy means bucket permissions, lot many things are there. Bucket object copy, if you want to copy from one bucket to another bucket. Of course, that depends on the every resources in AWS, right? So that's another example how you can create. If you know creating one resource, other resources would be the same. It depends on your requirement, what parameters you would pass. Coming back, either it is EC2 instance or S3 bucket, we just created with the basic details, like just the public, I mean, bucket name and the just the minimal permissions. Here also just the like the instance type and then the AMI. But what if you want to configure lot many things, like if you want to create your own VPC, your own subnets for your instance, and why you should have your own EC2, sorry, your own VPC and subnet to configure the networking things, network configurations and customize it. You can do this, right? So that's where we can customize our EC2 instance with all the network configurations as well. So creating EC2 instance with all the network configurations, we shall take up this in the next class. Any questions from anyone? In the next class, we shall see replication also. Like, let's say we are using this for a dev environment. How do you replicate for other environments? That also we shall have a look in the next class. Any more questions from anyone? Again, all the documents, all the code references I have added is available in the website. You can also refer to them. Any questions from anyone? So that is all from my end. Thank you all. Good day. Bye, everyone. Once it is all done, just destroy the infrastructure.